Okay. Sharing the screen. Okay, so hopefully everyone feels good about that, feels like you know what this concept is. It's very important when, right, we're mostly, you're going to use it with fractions, but it's also, you'll need it for algebra too. So, okay, so good. Okay, so number 2, and one thing to notice, and maybe you guys already are kind of aware of this on math problems, but you know, they like to give you a lot of what I call noise, right? So they're giving you all this information up here, but I mean, really you're focused on the question and I don't know, for me, I'm more visual. Maybe the story helps people, I don't know. So here, the volume of a recycling bin is 72.3 cubic feet. Oh, I guess that is an X. Sorry, that's a variable. Are you guys pretty good, or you guys feel confident about variables? They make sense and you know what they're doing and what they mean?
I feel confident, but I feel like I need some reassurance.
Okay, no worries. But at least when you see the X, you know that it's part of the math, right? At least. So yeah, so here is, yeah, cool. So we know the volume and we know the width and we know the length, okay? How do you guys feel about the concept of volume? Does everyone know what that means?
Length times width times height.
Good, good. So is volume a measure for 2-dimensional or 3-dimensional shapes?
3, right?
Yep.
3-dimensional.
Good, right? So anything that's 3-dimensional has a volume, and basically, right, it's the amount of space that it takes up, right? Or, you know, you can always think about volume, right? You measure volume in like measuring cups, right? Or you think about like scientific beakers, right? You need certain volumes of water and chemicals, right, to do all your experiments. So good. So good. So what is volume? What's kind of the equivalent of volume when we're talking about 2-dimensional shapes? Area. Perfect. Very good, Arnie. Good. So when we talk about, right, 3D, we've got 3 dimensions. So just like Nicholas already told us, right, we have width, length, and height. Now here we have to work a little bit backward because we have the total volume, but we don't know the height. So the other thing to know, right, about volume is, right, that you calculate it, right, using a formula. So when you look at, this is the last page. Oh, man. Okay, really, really bad. Not focus. Give us the love. Okay, never mind. But hopefully you guys can see. So these are all our volume formulas right here. So for every 3-dimensional shape, there is going to be, right, a volume formula. So the rectangular or cube is kind of the easiest one because, yeah, you're just multiplying your 3 dimensions together. Okay, but that's not what really the question's about. So hopefully everyone feels like you have, right, so here we have what's called an algebraic expression. Okay. So an algebraic expression usually representing something, right? So this expression represents what we would need to do to calculate the height of the recycling bin, right? This expression will allow us to do that, okay? And so the difference between an expression and an equation is an equal sign. So hopefully you guys kind of know that, but it doesn't really matter too much. But here's what we need to figure out, okay? Right? The value or values of X that makes the expression undefined, right? And remember, this is the expression. So what could we plug in to the expression for X that would make it undefined? Does anyone have a sense of what this means?
That one confused me.
Yeah, it's definitely more of a math concept. Terrellyn or Nicholas, have you ever heard this idea? I had to Google it too.
I believe that I have, but I to be honest with you, I do need a refresher.
So no worries. Yeah, like I said, I really feel like every time I teach math, I'm always like, we got to learn how to talk math because that's for me like half the battle, right? So good. So when we say undefined, it means so anytime you have a fraction with a 0 in the denominator, did I not spell it? No, I did.
It's all right, we understand.
So right, so basically, if you said like 3/0, it's what you would classify in math as undefined. What is that? Why do you think that is? Or what is this they want us to see or recognize or know?
Because 3 can't go into 0, so it's just 3.
Right. So whenever 0 is the denominator, right, you can't take anything and divide it 0 times, right? Does that make sense? Yeah. Because of course, whatever is the denominator, right, of our fraction has to at least be 1. Otherwise, it's not that it's, yeah, I mean, it just can't logically exist in math. And so what they're asking us here is, right, if we look at our denominator, what value or values of X, so what could we plug in for our X values that would make it into 0 on the bottom? Does that make sense?
Mhm.
So there's two possible values that we could make X that would make the bottom equal 0. 0, good, right? So, right, if we plug in our 0 here, right, we have 72.3 times 0 over 8 times 0 times 3. Okay, right? Anything times 0 is 0, so 8 times 0 is 0. 3 plus 0 is 3, but 0 times 3 is 0. So does everyone see how one of the values of X is 0? What would be the other value? And remember, these two are being multiplied together. So if we plug in a 0 here, that makes the whole thing 0. What would we have to put here that would also make it 0?
That would make that 0?
Mm-hmm. So, right, if we have 3 plus X, what would X have to equal to make that answer 0? -3. Do you guys see that?
Yeah.
Good. So same thing. Yeah, right. So this equals 0. So it makes the whole thing 0 or that. So hopefully you guys now know, I mean, clearly, right, when you know what it's asking, it's not that crazy, but hopefully you guys can remember this and know, right, okay, if it's asking me what I have to do to make it undefined, what do I have to do in the denominator, right, to make it equal to 0 and therefore undefined. So, good. Questions?
So the answer is 0 and negative 3.
Oh yeah, thank you. It is not a 3. Thank you. Yeah. 0 and negative 3 are the values of X that make the expression undefined. Yep. I don't know if I'm supposed to put them in brackets. Cool. So yeah. So while, you know, this isn't super like I said, it's just really noise. I mean, for some reason, it feels like that's what they do to us on math tests. Where like for me, I'm like, can we just cut to the chase and like not have to give me all this stuff when you really want me to do like this other stuff? Anyway, all right. How did you do on this one? So we need to arrange the list of numbers from smallest to largest. What kinds of numbers do we see in our sequence of numbers here, or our list of numbers? What kind of numbers are these? And some of them didn't copy very good, did it? So this is actually a decimal. Hopefully you guys can see that.
Decimals and fractions.
Yep, decimals and fractions. And what characteristic do decimals and fractions share?
Part of a whole number.
Good, right? They're all less than 1. They're all numbers between 0.99999 and 0, right? Or 0.0001, whatever, to infinity. Good. So of course we know that, right? We can represent that as either a fraction or a decimal. So one thing that's really helpful is to kind of know, like if you looked at 1/4, does anyone know what 1/4 as a decimal is? 1/4?
0.25.
Yep, good, right? And that's why we call a quarter, right? And why it's worth 25 cents. Does anyone know what 2/5 as a?
0.4.
Good. And so fifths are in multiples of 2. So 1/5, 20, or 0.2, right? 0.4, 0.6, 0.8. Good. And then 1/3.
Hold on.
Yeah, and you can always figure it out by dividing with your calculator. 1/3 comes out to, what is it called?
Point.
Like a repeating fraction. Yeah. So it's basically
0.33.
Yeah, 0.33333333. Yeah, good. So what would be the smallest number then among these 6 numbers?
A quarter.
Good. Followed by?
0.3.
Yeah. Then?
1/3.
Yeah.
2/5.
Yep.
0.6. 0.8.
Good. Good. So everyone, Terralyn, are you feeling good about decimals and fractions?
Yeah, just gotta refresh my mind also, so.
It's okay. What were you saying, Arnie? Sorry.
I got the 2/3 or the 2/5 and 1/3 mixed up.
That's all right. So, you know, that's where, right, we would look for the the least common denominator. Do you know how to compare fractions as far as size?
I think I learned it, but I don't.
So as opposed to our greatest common factor, here we look at our denominators. And we look for what's called the least common denominator, which is 15, right? So I can convert these into not equivalent fractions, sorry. So let's see. 5 times 3 is 15, so 6/15, and then 5 times 1 is. So yeah, if you can find the least common denominator, then it's easy to compare the size of your fractions. If you aren't seeing it, but no worries, no biggie. And so, like I said, for me, like, oh goodness gracious, should be a 4. Wow, But yeah, and so it is helpful to kind of remember, right? You've got your quarters, your thirds. Fifths are, like I said, I always think about 20ths, right? 20, 40, 60, 80 are your fifths. These are tenths, of course, right? 1/10, and of course there's 10 tenths, right, in a whole. So this would be 3/10, 6/10, which is really what, 3/5, so 60%, yeah. And then 4/5, right? All right. Well, good, Carolyn, as long as you don't feel completely lost and you feel like it's something somewhat familiar. Of course, when we were working with algebra, we'll probably work a lot more with fractions than decimals, but they like to throw in decimals just to make it hard. So just to make it annoying, like just to make you have to use your calculator or something. I don't know. I should be nicer. Hi, Curtis. Glad you could join us. Do you have this paper? I don't think I sent it, but hopefully you can follow along. Okay. Excuse me. Okay. So number 4, now we're dealing with roots and exponents. Okay. So what's going on here with just this first term?
First you got to figure that out, then you got to figure out the other one. Then
Right. So this is actually not a square root though, right?
No, it's not. It's a
3, right? Cube root.
Yep.
Yeah. And then here, right,
5.
we're raising 5 to the 3rd power.
So
So
basically,
how, what?
don't we do PEMDAS? Do we kind of use PEMDAS here or no?
In a way, yes, right? Because we got to do our exponents before we can do any subtracting or adding.
Yep.
So yeah, we want to take care of this and this before we can take care of the subtracting or the adding. So yeah. So does anyone know what this means or how we would figure out how to simplify this cube root?
Something times itself, it's going to make 125, right?
Something times itself, right? Because it's a cube.
Yep.
So yeah, so remember x cubed right? And so then if you took the does that make sense?
Yep.
So what number times itself gives us 125? 5. So the answer here is, right, 5 minus, and then what's 5 to the 3rd?
125.
125.
And so she texted me and said, "Oh, we're having hamburgers and potato
So
salad."
then, right, now that we're down to adding and subtracting, then you just, right, do left to right. So plus 5 minus 120 gives us negative 120, right? And then negative 120 plus 52 gives us negative 68. See if that was right. Great. So does that
You're
feel
cheating.
okay?
Vacuum right here, and it was like right on top of us. It was like
So yeah, exponents, roots and exponents first. Then if we get down to just adding and subtracting, then you work from left to right. Does everyone feel okay about number 4? Good job on that one, Arnie. When I first looked at this, I was like, oh, they cancel out. And then I'm like, oh, wait, never mind. They're 2 different numbers. Okay. Number 5 should be pretty easy, right? What is the distance in units between the 2 points? Pretty easy, right? You just count 1, 2, 3, 4, 5. So hopefully everyone got 5 for that. And the thing to know here is they're talking about the idea of absolute value. Have you guys ever heard that concept, absolute value?
Yeah.
Yeah, so it's basically saying, you know, it's the total number of units, and it doesn't matter if we're moving to,
It's the absolute value. It can only be, it can't be negative.
it's always it's always represented as a positive because we're thinking of it more in units and not thinking about the direction the units are moving. Does that make sense? That's kind of that concept there, yeah. Okay. How is everyone doing? Anyone feeling completely lost, or are we moving okay?
Notes right now.
Pardon?
I said I'm just taking notes right now.
That's very understandable. We're just dipping our toes right now. So, and just trying to get a sense of where it's best for all of us to focus. So, of course. Okay. So like I said, now we're into where we can use a calculator, although we might not need it. And we come into some word problems. So as I was saying, like my strategy and my approach is to always try and cut down as much of the noise as possible. Like I said, some people might enjoy the story of the math problem. I haven't really heard too many people who are stoked about word problems, but hopefully that makes sense. So we're going back to the concept of an expression, okay? And so remember, an expression is really like it's really like our formula. It's our setup to our problem, but we're not actually solving anything. We're just saying, if we were going to set up this scenario mathematically, it would look like this, okay? And so remember, expressions can have numbers, they can have variables, they can have operations. Not sure if expressions can have, do you guys know what these are here? The alligator mouths?
Greater than, less than, or
Yep.
equal to?
Good, yep. Just greater than or less than. If it has the line under the mouth, then it's equal to as well, but not quite there yet. But anyway, let's see what we got here. So the number of people in line for Disney World's Rock and Roller Coaster is P, okay? So once again, we haven't really determined the number of people on a given day or at a given time, so we're just gonna call them P, okay? And those are the number of people in the line. The number of people in line for the Dumbo ride is 250 less than 6 times the number of people in the line P, right? In our Rock and Roller Coaster line. So here it's telling us which expression represents the number of people in line for the Dumbo ride. Anyone got a guess?
A.
A. So you're saying that 250 is less than 6 times the amount of people in the line?
Correct.
And that shows us how many people are in this line? Maybe. So the key here is this language right here. So first we need in our expression something that talks about 6 times the number of people in line. And remember, the number of people in line is P. So what would 6 times the number of people in line look like in our expression? Well, hopefully you guys can see, right? So we have 6P here, 6P here, 6P here, 6P here, okay? So here, is it 6 times P minus, right? 250 less than 6 times the number of people in line? Or is it? So, like I said, and I'm sorry, I'm probably confusing you guys, but A and D are not expressions. They're called inequalities.
I would
So
say
expressions,
C.
pardon?
C sounds right then. I
Yeah.
mean, because if you're doing 6 times P, then you minus 250 from it, right?
Right, because 6 times the number of people in the line is 6 times P, and then 250 less than that, right? Which is
Right.
that chunk, yeah. So does everyone get why C is the answer there for number 6? So yeah, so a little bit of a trick question there. So when we say expressions don't have greater than or less than or equal signs, right? Okay. Yep.
Is there a name for all of those put together, for greater than, less than?
So if it's greater than or less than, it's called an inequality. And if it's an equal sign, it's called an equation. So like an expression, we can't solve, we only reduce it down to like its simplest form. Did you get C for number 6, Arnie?
No, I got D, but
Okay.
I didn't realize expression.
Yeah, so once again,
So it's, yeah, because the other 2 were inequalities.
yep, yep. And of course, right, they're trying to trick you into thinking it's an inequality by using less than because they're evil. No way around it. But good, yeah. So once again, if they're asking you for an expression, it needs to be a choice without inequality or equal signs.
The greater than or less than, is that considered an inequality too?
Yeah, those 2 signs are what we call inequality.
No, though, I'm saying the ones that have the line under them.
Oh, yes, yes,
Okay.
yes. Yeah, so no greater than or equal to, no less than or equal to. So yeah, so the expression is really our formula, and we'll always need something to plug into our expression to do any kind of calculation. Otherwise, right, basically we would choose any given day and figure out how many people are in this line, plug that in for our P, and then we know how many people are in this line. Although pretty hard to consistently be like, there's always 250 people less in this one line. But that's not the purpose of the question. Okay. All right, well, it is 1:30 and we got through, oh yeah, we got till 2:30. Why do I keep thinking we're done earlier than I did this earlier this morning too, guys?
That's fine.
I'm like, just like, let's get this day over with. Okay, let's keep rolling, actually. Okay. So Beverly wants to cover her patio with a triangular fabric tarp. You have a fabric tarp? I feel like tarp is very specific kind of fabric that's not fabric. But anyway, all tarps are plastic to me, but maybe I'm mistaken. No, you can have canvas tarps. Never mind. Okay, sorry, be quiet. Okay, the point is that it's a triangle, right? And so we know that the distance from point A to point B is 10 feet. And we know the total area of the tarp or the triangle is 28.35 square feet. Okay. So what is the distance in feet between points A and C? All right. So this is our regular equation for area. However, right, we are solving for, I mean, it's kind of hard to decide, but I guess we're gonna solve for our H. Okay, because we know that the base, okay, okay, so we know that B equals 10, and we know that the total area is 28.35, okay? So for the values we know, right, we should plug those into our equation. Oopsie.
And that's the equation for area for the triangle, right?
Mm-hmm.
Half.
Yeah. So once again, right, you just look at your formula sheet and area of a triangle. Yeah, right there. Yeah. All right. So now that we've filled in the values we know, we can solve for what we don't know. Okay. So we know that first we have to work inside our parentheses. So 10 times H is 10H divided in half gives us 5H. Does everyone feel okay how I got from here to here? So do my multiplying, then divide. And now what should I do?
Divide 5.
Yep. Good, right? So we want H all by itself, so let's divide both sides by 5. And here's where you need your calculator to do that final calculation. So the distance between points A and C should be about 5.67 feet. Let me check my answer. Please don't be wrong. Yay. So does everyone feel like you could work this problem out? We can definitely focus on geometry if you feel like that's something we need to go through in more detail. But remember that geometry, we generally are starting with some kind of formula and then plugging in what we know and then solving for what we don't know. And for some reason, my camera is like super tripped out today. How's that feel? Number 7, okay?
Yep.
Good?
Yeah.
All right. Okay, number 8. And I just kind of fixed the question because it was confusing, but so here when it says write a description, we're doing kind of the same thing as on, so we're going to come up with our answer should look like this, right? It should look like an expression. Okay. 6 less than the quotient of a number and 2. Okay. So anytime, right, you see this, okay, that's your variable, and they're not telling you what letter to use as your variable, but you can just use X. So then 6 less than.
So 6 minus X.
Well, we have the quotient of a number and 2. So what would that look like? Yes. So would it be, so if it's the quotient of a number and 2, what does that look like in like an expression? Which one's on the top and which one's on the bottom?
-6 over X. plus 2.
I don't think so. What I'm reading is the quotient of a number and 2 is X divided by 2. And then 6 less than that. I don't know. Let me check my answer. So I haven't checked any of my answers yet. But I'm feeling good. Okay. Maybe. Number 8. Yeah. Yeah. So yeah, these ones are kind of tricky, but yeah, right. So this is telling us divided. So the quotient of blank and blank just means you put the top over the bottom. And then here, when it says 6 less than this, then that means that it has to be over here. Does that make sense?
Yeah.
I mean, I guess you could have -6 plus it, but it would look, well, you're not going to have a machine or a person grading your test. So showing your work isn't going to help. It was like my lifesaver in math. Okay. So then what about number 8 there?
4x.
6. Pardon?
4x plus 6.
Yep. Good. So that one was a lot easier. Once again, right, these are expressions. There's no equals. We can't solve. This is basically as simplified as we can go until we get more information. Okay. Either we get a value for X or we can turn it into some kind of equation. Okay. All right, back to geometry. Okay. I like how illustrated this is. For some reason, I like all the pictures. I'm like, oh, look at the cow. Look at that thirsty cow. All right, George shopping for a water tank for his cattle, although he appears to only have one cow. Hi, Ryan. I'm not sure if I have. Let me go see if I have this. Okay. You'll need one for this class specific. Yeah, one sheet for every class. So we already talked about our rectangular prism. The next three-dimensional shape we're going to work with is a cylinder. So once again, this is the volume formula for a cylinder. So volume equals, do you guys know what this is right here?
Pi.
Pi. Okay, good. Pi times r squared times h. What is r squared?
4.
Well, yeah. R is the radius, sorry, yeah. R is the radius, and right, we figure out what the radius is because we know what's the capital D stand for?
Diameter.
Diameter, okay? So diameter, right, is our length from one side of the circle to the other. What is a radius?
Half of that.
Good, half. So we start at the center of the circle and go to the edge. And so we call this the radius, which is our R here. And they generally like to do this where you're supposed to work with the radius, but they always give you the diameter. So you have to just cut the diameter in half. Okay. All right. And so let's see, he finds several shaped like a cylinder and needs it to hold. Okay. So here's our volume, right? So anything, right, that's in cubic units is three-dimensional, okay? And that is a measurement of volume, okay? Cubic feet. That seems like a lot, but I'm not very good at, I'm like, can I even conceptualize what a cubic, I don't know. Okay, so this is our V. Right? This is our R, okay? And so here, the question is, how tall is it? So that is our H, right? Which is for height. Okay, so we're basically gonna do the same thing we did with our triangle. We take our formula, we plug in the values we have and solve for the value we don't have. So we know that 101 equals pi times r squared times h. Oh, so the other thing I forgot to mention, because you guys seem to already know this, right? Pi is what we call a constant. Does anyone know when we call a number or a symbol in math a constant, what are we saying? It doesn't change. Perfect, right? It always is a number that represents a very particular value, okay? So pi is like this crazy mathematical thing that happens when you calculate anything circular, both in area or volume. Okay, good. And so pi is always the same value. Usually they just have you put 3.14. I'm not sure. Well, I'll have to look at the answer. Is the answer numerical or is it with pi? We're going to talk about pi right after lunch. So good.
No, they round it off.
Oh yeah, they do. Oh yeah, thank you. Derp, round to the nearest foot. Thank you. Okay, so usually if you're asked to like do the full calculation, you're pretty safe in always having pi be 3.14. So let's go ahead and say 101 equals 3.14. Okay, 4 times 4, 4 squared is 16 times h. Okay, so then let's go ahead and, did I want to do that? Probably. All right, so let's do our multiplying. So pi times r squared gives us 101 50.24 h. Okay. All right. All right, and then we do the same thing, right? Divide both sides by 50.24. And that will give us our h. $101 divided by, and then we're going to round to the nearest foot. So, yep, 2, about 2 feet. So not very tall, very round, but not very tall, which probably good for a cow, because I'm trying to think how far it could. Yeah, if it's only 2 foot high, then they should be able to drink if it gets low. Anyway, doesn't matter. See, that's why I don't like word problems. They make me get off topic. Does everyone feel good about problem 9? So, what shape are you dealing with? What calculation are you dealing with? So we're dealing with the volume of a cylinder. Find your formula, plug in the values that you know, and then calculate what you don't know. How does this feel? Ryan, you see where we're at?
Yeah.
No worries. Whoa, sorry guys. Guys good? All right. So Tuba City's having a rodeo next week. Don't know if that's true. I've never been to a rodeo in Arizona. I probably should go. All right. Adult tickets are $12. And tickets for children under 12 years old are $8. Okay. Melissa sold 25 tickets and collected a total of $224. How many of each type of ticket were sold?
Does it matter?
According to answering this question, yes.
I would say 18 adult tickets and 1 children ticket.
Okay. 8.
Let's see.
So here, right, we need some expressions, right, to help us figure stuff out, right? So, right, we know that. So there was $224 total dollars, right? And so we have 25 tickets.
Like 15 tickets.
15 of how many? right? If we call adult tickets X and children tickets Y, right? Because we have two different groups. We have adult tickets and we have, right? And so some combination of adult tickets plus children's tickets, right? Totaled 25 and came out to a total of 200, sorry, $224.
16 and 4.
Okay. 16 adult tickets.
16
four-
adult, 4 children.
Okay. How'd you figure it out?
Me?
Yeah.
I just kept on doing different.
That's definitely one way to solve this problem.
I just kept on doing different because I didn't at first I didn't see the I didn't read it right, so I didn't realize that it was a total of 25 tickets that were sold. So that's why I was saying 18 adult tickets and 1 children ticket. That does add up to 224. But to get 20, that's only 19 tickets. So we're trying to get 25 tickets. So I just started plugging in $12 into $224
Okay.
and to see what
See
else
what was left over.
what was left over for $8 tickets. But that's
Nice.
that's the harder way to do it.
So yeah, you could kind of do it like that, right? Yeah, and say like, okay, about 18 adult tickets would be what?
216.
Yeah. And then you just need how many more to get to 24?
Just 1.
One.
Yeah, but that's not going to give you the right answer.
No, that doesn't give you 25 tickets yet. So yeah, you can definitely do it this deductive way. So if we're going to try and solve it numerically, right, we have to think of how to talk about these two groups in terms of each other, right? So if adult tickets are $12 and X, right, and 12-year-old tickets are 8, then we could say, right? Would that be the same? Because
Yep.
if X equals 12, then X minus 4 equals 8, right?
Yep.
So we've got 224 total dollars from 25 tickets. Right? So does this make sense? So I just call one variable one thing and then talk about the other variable in terms of the first variable.
Okay.
How does that sound? We'll see if this works because I don't really know. Okay, so if we're going to solve this, we're going to work inside our parentheses. So X plus X is 2X minus 4 times 25 equals 224. Okay, now I'm going to do this, right? So I have 100X, right? Oh, wait, 50X, sorry. Ah, my pen. Sorry. 25 times 2X is 50X. 25 minus negative 4 is negative 100. Okay. And then we're gonna add 100 to both sides. So we end up with 324 equals 50x. See if this will work. It's not gonna be even. Okay, so it looks like if I have 6 adult tickets, no, that's not right.
How did you
I totally messed this up somewhere.
how did you get a negative 100?
Because I'm calling children under 12, X minus 4,
Okay.
25 total tickets. Maybe I don't need the 25. Do I need the 25? Sorry, this always happens to me. Let's see. Because 6 adult tickets would just be $72. So. Oh no, that's way more. Hmm. All right, I'm gonna have to table this one until Monday because I'm not exactly sure where I'm messing this up, but I am messing this up somewhere. So if you did 2x minus 4, 2x minus 4, if we take the 25 away, minus 4, and then, so you'd have no. Yeah, I'm gonna have to work on this one, guys. Sorry. There's probably 2 okay, wait. I think I remember now what to do. Okay, let's try again. Maybe I can make this work. Since we have two unknowns, then we have to have 2 equations to kind of solve for them. So let's start over, okay? Sorry. Okay, so we know that, right? However many number of tickets. So we have 224 equals right? So we know that we have a total of $224, and we have the unit price of the 2 tickets, right?
I think I got it.
Okay, what did you do?
I just took the multiple numbers.
Yeah. I know, I'm sitting here forcing you guys to like. Okay, and so this is the 2 things that we should know is true, right? That the total number of adult tickets is the same as the total number of, the adult tickets plus the children's tickets equals 25, right? And we know that the price of the adult tickets plus the price of the children's tickets should equal $224. So do you guys agree that both of these are true? Hopefully.
Yeah, so we're both 224?
No. So this is representing, right, the, what would it say? Total ticket sales.
Oh, yeah.
And that's why we have the 2 ticket prices here, right?
Yeah.
And then the 25 is our total tickets sold. Okay. So if we can, once again, right, if we can think of our Y in terms of X, then we should be able to solve by plugging that in. But I'm not sure which order now. Yeah, sorry guys, lost my steam. But I mean, this is basically what you guys are working out, right? We're just not figuring out how to do it algebraically because I'm not a math teacher. So let me just play for a quick second here. So. Still not coming out very evenly here. Yeah, still, I gotta work on this one. Okay, I give up. We'll be okay, guys. I'm so sorry. Okay, we'll get there though. I will look at that and work on it some more. I know it's like this 2-stepper thing that I've got to remember how to do. But you guys seem to have good enough reasoning skills. You don't even need to know how to do it the algebraic way, right? Okay. Whew. Hanging in there with me, okay? All right. Anyone feel good about this one?
The solve for X.
Yeah. Number 11. Yeah. So because, right, we have this X squared piece. Yeah, that is what is going to kind of make this hard. Okay. So in order to solve this, we have to use a formula from our formula sheet. And it is known as the quadratic equation or quadratic formula. So the first thing we need to do is transform this by moving the 6 to the other side of the equal sign. So we want our equation to start by looking like this. Okay. So if you have a problem that has an X squared, an X, and then just another number hanging out, you have to use the quadratic equation or formula to solve for X, okay? So the terms here This number by the x squared, we call A. This number by just the x by itself, we call B. And then the one without a variable, we call C. Okay. So then let's look at our formula. So we know that X equals so this is our formula, okay? So you can see how, right, we'll put our B's in for our B's, we'll put our A's in for our A's, and we'll put our C's in for our C, okay? So X equals, now, negative B, if we have a negative of a negative, what happens?
It's a positive.
It's a positive, perfect. So, right, since we have negative B and B is already negative, it'll be positive, okay? Then we have plus or minus, and this here means that all of these equations have two answers. Because we have to do a plus and we have to do a minus, okay? But we'll keep working before we get to that step. All right, and then B squared, so negative 7 squared minus 4 times A times C over 2 times A. Okay. Does this look okay for everyone? All right, so let's work inside, right? We need to simplify everything under the radical here before we can do anything else. So negative 7 squared is positive 49. So, and here maybe we'll, yeah, so we have 7 plus or minus the square root of 49 minus 48 over 2 times 2 is 4. Okay. So of course, 49 minus 48 is 1. What's the square root of 1? 1. Good. So we end up with 7 plus 1 over 2 and 7 minus 1 over 2, right? That's how I break out my plus and my minus. So when I solve here, 7 plus 1 is 8, divided by 2 is 8. So X can equal 8, or sorry, 4, sorry. 4, or 7 minus 1 is 6. And so 3. Halves. 7 minus 1 is 6. Or no, and then 6, yeah, so just 3. Oh, no, wait, over 4, sorry. Sorry, guys, goodness gracious. All right, let's start over here.
Okay, wait.
Yeah,
You know how it shows us how to get the quad or how to do the layout formula for the quadratic equation
Mm-hmm.
for the quadratic formula. So basically, you know how it says 4a times c.
Mm-hmm.
That's what you're gonna plug in there. But if I was to read that and I wouldn't have seen you put in 48 for that, I would have thought that I would have put in. I thought I would have put in A, which is 2, and then C, which is 6. Oh yeah. Wait, never mind. No, don't listen to me.
It's okay. It's okay. We're all in the same boat here. Okay, so now that I've got my denominator correct, 7 plus 1 is 8. 8 divided by 4 is 2. 7 minus 1 is 6 over 4. We can reduce 6 over 4 to 3 over 2, or 1 and 1/2.
Is it all right if I log out kind of early?
Yeah, that's fine. Whenever you need to go about your day, I
Yeah, 'cause
understand.
I got to clock into work here in a minute. We have a meeting.
Sounds fun.
But I will be here. What is it? Wednesday?
Yes, yes, good.
Okay.
Hopefully everyone remembers Wednesday is a holiday, so the college will be closed, so we won't have class next Monday. Sorry, next Monday is a holiday, no school on Monday. It is, yes. You got
guys have a great
plans?
weekend.
Bye, Nicholas. Glad to have you today.
So no class on Monday?
Yeah.
Okay.
Yep. No class on Monday. All right, John. So like I said, so yeah, whenever you see your equation has this squared and the x part and the c, then you have to set it up like this. Use the quadratic formula, plug everything in, and get your 2 answers. Okay, so if you feel like we need to practice this more, we certainly can. This is kind of advanced algebra, but hopefully it makes sense. I don't know if everyone's kind of seeing how it works. All right, John's responsible for a team building exercise for his company and found a local business that offers zip lining. Well, that sounds fun. The manager charges $100 for setup and $15 per person. So the total budget is $500. So here, what is the greatest number of employees that can attend? So this is what we call an inequality. Right? So we start out with our budget of 500. That's all the money we have. So we have to make sure that everything that we pay for, right, is less than 500. Does that make sense? Yeah. So we know that it's $100 setup. And then, right, plus, right, our $15 per person. Okay. Does that look good? So now we can solve this like an equation. So we'll subtract 100 from both sides. So then we can divide both sides by 15. So because, right, so when I do my last step, right, 400 divided by 15 is not a whole number. So what is the greatest number of employees that can attend? 26, right? Because we probably shouldn't be dividing people up into thirds, right? Like only 2/3 of you can come. The other third of you has to stay in the office. So does that make sense? This idea of what is the greatest number? So 26, right? How did I do? Did we get it? Yes. All right. You out of here, Ryan? You gotta take off? Oh, okay, no worries. Okay, hang in there with me, guys. We just got a little bit more, but like I said, hopefully feeling pretty good about this, but giving me a sense of where we need to focus. Jose opened up a new taco truck called Walk and Roll. Oh, that's kind of fun. The first day was a big success and he made $1,200. On day 6, he made $1,850. Jose assumes the earnings will continue to increase at the same rate. So how much will the food truck make on day 12? So we kind of have to figure out what is the increase and then keep increasing that. Does that make sense? So if the increase between day 1 oops, goodness. Okay, and so it should be a steady change. So we look at the change from here to here and then apply that same change, right, from here to here. Does that sound like a good plan? Hopefully it'll work for us. All right, so to find kind of the difference here, we'll just turn this into, so how much more is 1,850 from 1,200? All right. So that's about right, a 60, what do we have to, it doesn't tell us around. It's like a 64% increase, right, between here and here. And so it increased steadily, right? 64%. we might have to come back to this one on Wednesday too, because I'm getting lost and I apologize. At the same rate. Yeah, let me get back to you guys on this one because I know I'm kind of feeling good, but I'm not feeling super, super good. Let's try and get through these last two that I know I can probably do. Like number 14 should have felt pretty easy-ish, right? So if letter size paper costs $17 per case and legal size paper costs $23 per case, how much did company C spend on those two sizes of paper? So we're looking at company C. So basically, right, 2 times 17 plus 3 times 23. Pretty straightforward. Does that make sense? Yeah. So just you make sure you can find the information in the table and then calculate your costs. So let's see. 3 times 23 plus 34. So they spent, whoops, $103 on paper in January. Yay. All right. And then we have one more volume problem here. So now, right, we have the three-dimensional shape we're looking at is a pyramid. And they show us the volume of the pyramid. And then they give us the base of the pyramid and the heights. Oh, wait.
What was the volume?
The volume, 668. So yeah, so 600. 12 feet by 12 feet is 144, right?
So that's the formula for the volume of the pyramid.
Mm-hmm. 1/3 the base, which is actually a measurement of area, right? The base of a pyramid is usually a square.
Okay. So
So the area of the base is actually 144. I don't think it's the length. Let me. Oh, shoot. Oh, per PS. Oh, yeah. Yes. Sorry, I copied it down. Oh, no, I'm looking at surface area. Shoot. Okay. Yeah, 1/3 base times height. So we'll start by, let's take 1/3 of 144. Oop. Whoopsie doodles. Oop. So 48 H equals 668. And then we just divide both sides by 48. Round to the nearest foot. So let's round that 13.9 up to about 14. And then let's confirm our answer. All right. Great. Okay. How are you guys feeling? Is this too hard? Just right? Super easy?
the pyramid is always, if there's like, say it was just at 12, you'd multiply it, you'd square that, right?
Yeah, I'm sorry. So in the formula, it's actually capital B base, which is the area of the square.
And the area would be 12 times 12.
Yeah.
So 12 squared.
Yep. Any other questions or concerns? So we've got quite a few more problems to work through and a couple to come back to. So do you guys think it's still helpful for us to keep working on these problems together before we start a formal lesson? Or do you guys want to start an official lesson on Wednesday? Yeah, I think possibly we could get them finished up on Wednesday. So I think that's a good goal. So yeah. So no class on Monday, but if you have time to work on the remaining questions, try to work through as many as you can on your own in preparation for class next Wednesday. Okay. And then I'll see you guys then and hopefully figure out these other two problems. That top drawer there. And, yep. Thank you. Ryan, you good?
Yeah. Keep this here.
Yeah. Put, oh, do you want a folder to keep your materials in or it's too small for your bag? Okay. Do you want me to hold on to it for you or do you want to try and take it home? And work on it a little bit?
I think at home.
Okay.
Is it back on Monday, is it?
So
Or
remember
Tuesday.
Monday's a holiday, so yeah, class on Tuesday. If you want to come in at 10,
Yeah.
you can. Or we'll have social studies next Tuesday. Well, I mean, there's class tomorrow. So you can come in at 10 tomorrow. Okay? See you then. Curtis, did you have any questions or anything, or are you good?